When I talk about the R&D process, and that's research and development, longhand, I like to use a quote from Albert Einstein. If we knew what we were doing, it would not be called research, would it? And I'd like to start this way because very few things that start in research ever end up as a drug product. And that's one of the points that we're going to cover today when we look at the actual development pathway. I learned this lesson when I was in graduate school. And I think all of us can speak to the need to go through many failures before we have a success. And you're going to see that that is clearly the case when it comes to drug development. So if you take a look at the chart that is in front of you that represents the drug development process, you can see that you start at an early stage that we call drug discovery, and you work through preclinical. And the next big chunk is when you do your clinical studies, and then once you get through the clinical studies and you've passed through all of these hurdles, you'll go into your marketing and post-marketing phase. But one thing that you need to understand that at the very early stages in discovery, you may start out with anywhere from 5, 10, or 20,000 compounds. And you go through a screening process that whittles those down, that by the time you go to the next stage, which we call preclinical, and it's designated that because it's before you go into the clinic. When you get to that stage, you may have about 250 compounds from those tens of thousands that you looked at before. Over another series of experiments in characterization, we advance a more limited number into clinical trials. And these are just a handful that go into clinical trials. These are sometimes can be as few as 2 to 5 compounds. Again, that started out from that group of tens of thousands of compounds will go into the clinic. What's happening throughout that process is that we are testing them to make sure they're working in the way we want them to work. In other words, if we're trying to target a certain disease such as asthma, we'll see whether it's working in a model that will help predict whether it's going to work. Then you have constraints as to the types of physical and chemical characteristics of the actual molecule, whether that can be made into something that can be turned into a medicine. And we will go through all of these types of barriers that you must cross before you can get into even a human clinical trial. Once you do pass into the phase where you're going into clinical trials, this is a very long and expensive process. So the number of drugs that go into this phase are limited not only by what could work to help a disease, but also by the expense it's going to cost to move it through that cycle. So let's talk about that cost. The average cost to develop a drug product is about $2 billion. Back in the 1980s, that number was about $100 million. And you can see that over a 30 to 40-year span, that number has just risen significantly. And there are many reasons for this. You can take a look and compare pricing from 1995 to 2000, and then look even just 5 years later in the 2000 to 2005 segment, and see that it increased from about 1.1 billion to 1.7 billion. If you look at the color codings, and you can see that in that time period there was a slight increase in the discovery research costs, and that's signified in the blue. The preclinical, which is a very small sliver of the green, may appear small, but the costs also went up somewhat, as well as the early phase 1 clinical trials. And we haven't talked about that yet, but the clinical trials are divided into phases. The early ones that have fewer patients are called phase 1, and as they go into phase 2 and phase 3, you have more patients. So if you look in the one that is coded with orange, and as your phase 2 studies where you're you have more patients that are enrolled, there are significant increases in the costs. Similarly, with the phase 3 studies, there's even a greater increase in the costs. And finally, the launch of these products has also increased in cost. So you can see that almost every phase has increased in cost, making it not only a long process, but an even more expensive process as time goes on. So let's go back to our original diagram and go a little more in depth on each of these phases so you can get a greater understanding and appreciation for what is happening. What you'll see in the graphics is in the early discovery phase, you may screen tens of thousands of compounds before you find one that hits the target that you're looking for. It's almost like looking for a needle in a haystack. And as you go through those processes to narrow down those drug candidates, what you're looking for is the best potential for being able to achieve a very specific result. You can think of a lot of different diseases. If you're trying to treat cancer, you want to stop the growth of cancer cells. You want to eradicate them. If you want to treat something, it might be a skin condition that you're looking for a very clear endpoint in what you're trying to do when you're in the drug discovery process. There are some standard ways to screen potential drug products to see whether they meet these certain criteria and advance to the next phase. But don't forget the Einstein quote. Most of those that are screened do not move on to the next phase, which is what we call preclinical.